Well, hey there, kiddos. Today we are going to talk about determining dependency and independent and dependent variables. And what we're trying to do is just decide, and just like when you do in science, you have independent and dependent variables, we also have them in math. And we deal with them a lot, and knowing what is independent and what is dependent is very important, especially when writing equations. And being able to determine that's a big skill. So the first thing I want you to do is I want you to fill in this table. This table is really pretty important because all of these words down the left-hand side over here are all synonyms of each other. Apologize, I took a deep breath. These are all synonyms, which means they all mean the same thing. The independent variable is the same thing as x. So x is always your independent variable, which happens to be your domain, which could also be your input. And these are all words that mean the same thing, and it's the same down the right-hand side. All of these are all synonyms, and they all mean the same thing. And so I need you to have this table filled out so that you can refer to it. And when you're asked for the dependent variable, you can go back and be like, oh, well, that's the y values, or that means that's the range, or all of that. And you won't know what all of these things are, but as you hear them, you'll be able to refer to this chart and go back and look at it and see, oh yeah, that's what that meant. So you might have to pause, but go ahead and fill out that table so that we can use it as we go through things. So the first thing we're going to do is we're going to take these statements and we're going to rewrite them to show dependency. And so we're going to rewrite it in a way so that we can say this depends on this, and then we're going to rewrite it, and then we're going to label what's independent and what's dependent. And so what you know, number one, is an employee who works longer hours will receive a larger amount on her paycheck. We got to rewrite the sentence so it says the blank depends on the other blank. So the things that we have that we're dealing with is an employee working longer hours gets a larger amount on her paycheck. So the two things that we're really dealing with is the number of hours that get worked and the amount on the paycheck. And so I want you to ask yourself, just think in your head and be like, self, if I were thinking about this, which would depend on the other? Do the number of hours I work depend on how much money is on my paycheck, or does the amount of money on my paycheck depend on how many hours I work? And so hopefully you have asked yourself this question, and now you're like, well, self, the amount of my paycheck depends on the number of hours I work. That's an F. This is true if you're getting paid by the hour. Not everybody gets paid by the hour, but at your age, that's pretty much how it works. You get paid by the hour. So how much your paycheck is depends on how many hours you worked. And so based on that sentence, if the amount of the paycheck depends on something, then the dependent variable is the paycheck. So how much is on the paycheck is dependent. What's independent would be the number of hours. So let's do another one. A box with several books weighs more than a box with just a few books. And so I have two things. I've got the weight of a box and the number of books in it. And so again, ask yourself, say, self, do the number of books depend on the weight of the box, or does the weight of the box depend on the number of books? Hopefully you asked yourself this and yourself said, the weight of the box is a function of, the words is a function of is the same thing as depends on. It means the same thing. So the weight of the box is a function of, or it depends on, the number of books in that box. The more books, the heavier the box. Hopefully that makes perfect sense to you. And so now they've written it backwards. We want to do independent and dependent. Well, if the weight of the box is a function of the number of books, the weight of the box depends on, so this is your dependent variable, the number of books. So the number of books would be independent. Because I need to know how many books there are in order to find out the weight. So the weight depends on how many books there are because I need information to find it. I can just look at it and be like, well, that's how many books there are. To figure out the weight, I have to know how many books. And so the last one, the fire was very large, so many firefighters were there. So I have the size of the fire and the number of firefighters. So we're going to rewrite the sentence so that it is a dependent statement. And so ask yourself, we got to ask ourselves this question. Does the size of the fire depend on how many firefighters show up? Or does the number of firefighters that show up depend on the size of the fire? And there are some, ways to think about this, okay? If it's a little bitty house fire, are 15 fire trucks going to show up? Probably not. If it's a little bitty house fire, somebody's cooking in their kitchen and they caught their oil on fire and they called the fire department, probably one fire truck is going to show up. But it's a big warehouse full of books and that caught fire. There's probably going to be a lot more fire trucks show up because the fire is now larger than the grease fire in the kitchen down the street. And so the number of firefighters totally is going to depend on the size of the fire. So to rewrite our sentence, we're going to say the number of firefighters I think that's such a great word, by the way, firefighters. It depends on the size of the fire. And so since I wrote it that way, my dependent variable is the number of firefighters because that's the thing that depends on something. So the number of firefighters depends on the size of the fire. So independent is the size of the fire. And that's just some ways to look at it. Now, it's not always this clear cut, but that's why we talk about it when we practice it, so that when we come across one that's not this clear cut, we can rationalize ourselves through it. So let's do a few more examples. So now here's what we have. We have the student council's planning to raise money by selling Halloween ghost pops. They're not taking orders in advance, but hope to sell 2,000 of them. The cost to order the ghost pops from Patty Polly's Pops, that's a mouthful, is 10 cents each. The student council will sell the pops for 50 cents each. And so this is their equation. Okay? This is the equation that they're going to use. Y is going to represent their total profit, how much money they made. X is going to be the number of ghost pops that they sell. And so it's important to know what those things represent. So now let's talk about this. A mathematical blank expresses a dependency relationship. One quantity depends in a systematic way on another quantity. Mathematically, the above situation can be described by the function. Well, a mathematical function, which is a word you've heard but we haven't talked a lot about, but a mathematical function is one that expresses a dependent relationship. If we're talking about something being a function, we are talking about it in terms of the fact that there are two things, one depends on the other. So using the description of the situation about the ghost pops and the student council, we have to determine the following: what's independent and what's dependent. Well, we wrote it out in our equation. I told you what represented what. So Y is going to be the total profit, how much money they made, and X is the number of ghost pops. So those are our two variables. I've got to decide which one's independent and which one's dependent. So we're gonna think about it. Does the profit the student council make depend on how many ghost pops they sell? Or does it work the other way around? Does the number of ghost pops they sell depend on their profit? Well, if I'm thinking about it this way, I don't think they're even going to know their profit till they know how many ghost pops they sold. Because they didn't sell them ahead of time. They're only selling them up front, right there. You have to come and get it. You couldn't walk up to the table and be like, I want 10 of them tomorrow. You just have to walk up and buy 10 of them today. And so you don't know your profit till you know how many ghost pops you sold. So the dependent variable in this is going to be the total profit. Because in order to find my profit, I will have to know something. And what I will have to know is the number of ghost pops that get sold. So the independent variable is the number of ghost pops. Because that's the thing I need to know in order to answer what the total profit is. So the total profit's dependent because I must know information. There's something I have to know to answer it. So we're going to write that as a dependent statement. So we're going to say the total profit depends on the number of ghost pops. But then the next question turns it around. The next question, they want us to fill in the blank, but it says blank determines blank. Well, if the profit depends on the number of ghost pops, then the number of ghost pops determines my total profit. And the reason why it works that way is because I have to know how many ghost pops there are to figure out what my total profit is. So the number of ghost pops determines what my profit was. So this minus 200 that happens to be in our problem, we got to figure out where that came from. And if you happen to look at the problem, the words, there's not a 200 in there anywhere. And no, it's not a misprint. It's not supposed to be 2,000. It is actually supposed to be 200. And so if you think about it, why on earth would the student council have to subtract 200 from this in order to find out what their profit's going to be? Well, if they have to subtract 200 from it, my guess would be that's how much money they spent on ghost pops to begin with. So that $200 is going to be, the money that they spent up front. So that's how much money they spent to buy the ghost pops. They had to pay for them first since they didn't sell ahead of time. That's how much money they spent up front for the ghost pops, and so they have to subtract that from their profit because we have to put that $200 back because they've already spent it. So that's how much money they spent up front to buy them. So let's do a couple more examples. So I'm a heavy foot, rammed her car into the garage door while she was texting because she wasn't paying attention because she was texting and driving, and we all know that's bad. Overhead Door Company charges $750 for a garage door plus $40 for every hour it requires for installation. If X is the number of hours for installation, so it tells us right here X is the number of hours, and Y is the total cost, here is the equation that describes that situation. 40x plus $750, $40 per hour plus $750 for the garage door. So we got to talk what's independent and dependent. Well, the way this equation is written, whenever you have an equation, you got to decide independent and dependent. The variable that's all by itself is the dependent variable because I have to know all of this to know that one little piece, which means I need information to find it. So your dependent variable is going to be the Y, so that would be the total cost. The independent variable is going to be the other variable, which in this case is X, which stands for the number of hours. And so we're going to write it as a functional relationship, so we're going to write it in a sentence. And so is a function of is the same thing as depends on, so the total cost is a function of the number of hours. But then if I want to write it in a different way, and I'm going to say this affects that, well, the number of hours that they work affects the total cost. And if you think about it, that makes perfect sense because however many hours they are there installing that door is going to affect or change what your total cost is. If it only takes them an hour to put it in, you're going to pay less than if it takes them 5 hours to put it in. So the hours affect the total cost. So now brook trout and brown bear are climbing Long's Peak in Colorado. They start the day at 2,130 feet and can climb 1/2 mile per hour. The independent variable in this situation is, well, the first thing I got to do is figure out what are my variables. Okay? I know that they can climb 1/2 mile per hour. This per hour means I've got to multiply the number of hours times their speed, which is a 1/2 mile. So the hours is going to be one of my variables. So I have two variables, the number of hours. And the other thing that I'm going to know is their total distance. I'm going to be able to find out how far they climb. So I have their total distance and I have how fast, the number of hours they've been walking. So I have the number of hours and the total distance. Well, if I'm thinking about those two things, in order to figure out my total distance, knowing where I started and how fast I can walk, I'm going to have to know how long I've been walking to figure out my total distance. So my independent variable is the thing, is going to be the thing I have to know to find out the other. Well, in order to figure out my total distance, I have to know my number of hours. And so you can think about it this way. The number of hours I've been walking does not depend on my total distance. My total distance in this case is going to depend on how many hours I've been walking. I know an argument can be made for it the other way, but the way this problem is set up, that's not how it works. And just for the record, very, very, very rarely is time, any measure of time, going to be your dependent variable. Only very occasionally, in the once in a lifetime math problem, is time going to become your dependent variable. More often than not, something else depends on time. We don't usually walk around having time depend on something. So since this is my time, that's going to be independent. So the independent variable is the number of hours. So we got to write an equation to represent this situation. Well, if y is my total distance, and I know that I can go a half mile per hour, so I can go 1/2 mile for every hour that I walk, and I know that I started at 2,130 feet, I have to add that to my distance by hour. That will give me my total distance, and so that's what your equation looks like. So now let's just talk about it in terms of some equations. The volume of a sphere, that's what this equation is, because that ball is a sphere. Okay, nice round three-dimensional figure. The volume of a sphere is given by 4/3 pi r cubed. I have two variables here. I know that there are three symbols, but only two of them are truly variables. This is a variable, volume is a variable, the V stands for volume, and the other variable happens to be r, the radius. Pi here might be a symbol, but it's not a variable because we know what pi equals. There is a number we use for that, and it's always the same number, makes it not a variable. So like I told you before, when you have an equation and you want to find independent and dependent variable, the dependent variable is always the variable that is all by itself. So in this case, the dependent variable is the V, which stands for volume. And that's because in order to find the volume, I have to know what the radius is. So my independent variable is the radius. That's the thing I have to know to find out the other thing. So one last one. I have 3/4 x minus 5 equals y. I don't even know what the y and the x stand for, but it doesn't really matter. I have an equation. Y is all by itself, so the dependent variable is y. The independent variable in this problem is x. Because the y is by itself, I have to know what x equals to find out y. Whoops. That's for later. So that is independent and dependent variables. That's what we're going to practice tomorrow in class, and we're also going to practice this Friday in class. So we're going to do a lot of practice with independent and dependent. It tells you it's probably very important. So I will see you tomorrow. Have a good rest of your evening.